I welcome you in this session of thermodynamics again. So as we know that we will start a special series of your boost the gate score. That means if you have any problem regarding the journey of preparations of any subjects, or if there is any confusion while you are preparing the subject, just this series will be very helpful to you to score the good score in the upcoming GATE 2024 examination. My dear, in the previous session, we will discuss all the related problem related to the basics law of thermodynamics. That means first law of thermodynamics, and first law of thermodynamics have a three domain: closed system, open system, and unsteady flow problem. And also we have to solve some problem of a second law of thermodynamics, in which we have to design the engine, reversible engine, and what is the reversible engine, what is the irreversible engine, how to differentiate with these two one, and with the help of Carnot principle. And also we have to solve some numerical problem related to this one, and also we have solved one numerical problem regarding the entropy. So my dear, we know that entropy is the measurement of the extent of irreversibility. That means higher is the higher irreversibility, higher is the higher entropy generation. That means a generation is nothing, it is indirectly says that how much the extent of irreversibility. That means a reversible process, how much the deviation, how much the extent of deviation will take place, and that will measure a quantitative parameter known as dq by t. Okay, integration of dq by t. And we know that according to a Clausius inequality, the integration of dq by t is less than equal to 0, and we have to solve the one problem. Now, with the help, what is the motive of today's classes? We will solve again the related to the entropy problem, and also we have to try to solve a advanced numerical problem of advanced thermodynamics, in which I will include the steam turbine, that means a Rankine cycle, and also the vapor compression refrigeration cycle, that means a refrigeration system cycle. And also we have to solve a one and two problem of the air standard cycle. That means we have to assume that a air standard cycle act as an ideal gas and operating in a closed system, and we'll solve that air standard cycle like Otto cycle, diesel cycle, like that. So today is the motive of these classes. Okay, so we'll start the today's session for this problem. Okay, so today's problem is first problem is this one. That means this is your first problem. What is the first problem? Please read the carefully. This problem is a very basics problem. And what is the problem? It says that, see, my dear, we know that there is a throttling device. This is your throttling device. That means the fluid will in and out, and we have to control the flow of the fluid with the help of valve. And that valve act as a throttled valve. That means during the throttling, one thing is must be noted that the pressure will be dropped. That means the exit pressure at exit section will less than the at entry section. But we cannot very surely say that temperature also will drop. No, pressure must be dropped, but temperature may be decrease, may be increase, or it maybe doesn't change regarding about the fluid flow. Okay, so what is that in the throttling process? And second thing is that during the throttling process, the throttling is a highly irreversible process. Why? Anyone can tell me why the throttling process is irreversible process? Anyone tell me why the throttling process is irreversible process? See, my dear, any process whose cause to irreversibility have a two distinct parameter. So any irreversible process, so any process makes the irreversible. Any process to make the irreversible process have a two distinct categories. First one is the lack of thermal equilibrium. That means if you transfer the heat from a finite temperature difference, finite, that means a certain value of a temperature difference, during that one, the process is a irreversible process, and that will cause the external irreversibility. That will cause the external irreversibility. Now, number second cause, the domain of the irreversibility is due to the internal irreversibility. The very good example of internal irreversibility is the lack, that means a dissipative effect. dissipative. And what is the cause of dissipative effect? The main cause of a dissipative effect is due to the fluid friction or a dry friction or a wet friction. That means a viscosity or a friction. That means the friction causes the dissipation effect, and that will cause the dissipation effect due to cause by, and the result of this dissipation effect always will be increase its internal irreversibility, and also there is a mixing is there. Also there is a unstrained expansion. That means expansion takes place against a very low pressure. Expansion against takes place a very low pressure. So this is your irreversible process and caused due to the expansion against a very low process. That means fluid will expand. That means how can you say that the fluid will expand? That means fluid flow from high pressure to low pressure, very low pressure. That means during the expansion, the process must be a irreversible process, and that is your internal irreversibility. So throttling is a irreversible process, highly irreversible process, and during that the entropy generation must be a greater than zero. Must be a greater than zero. Now, what is the question? Please write the question. Read the question better. A steam. That means a fluid, and fluid is a type of steam. And at inlet to the throttling, this is the throttling valve. This is the throttling valve. At the entry, the fluid pressure you can measure, and the fluid pressure is a 7 megapascal, and at the inlet temperature it is a 450 degrees centigrade. Okay, throttled, that means a throttling. What is the method of throttling? To reduce the area. That means if there is a flow, if there is a pipe, in the pipe there is a fluid is flowing, and if you try to restrict the area of that flow, fluid automatically throttled. That means if you are supposed to be stop the fluid, that is your throttling process. So we have to reduce the area. That means if you close the valve, the area of the passage will reduce. So automatically this is the throttling. So during the throttling, we have to reduce the we have to try to close the valve. That means the area that the fluid which is flowing through this passage have a constrained area. Okay. So throttle in a valve to a pressure. That means what is at how much the level of the pressure to up to throttle? The throttling is your 3 megapascal. So this is your high pressure and this is your low pressure. That means throttling, during the throttling the pressure must be reduced. Okay. Now this says that the flow is steady. What is the mean by the flow is steady? That means what is the property will change with respect to a control volume. If you take the throttling as a control volume, during that there is no change of the property with respect to time. That means all the property are inherent. That means independent with respect to time. Okay, determine now the second what they are asking that determine the entropy generation. That means the entropy generation during this process, how much the entropy will generate. Okay, now my dear, what is the entropy generation? So entropy generation is the system property. Is your system property. That means it is within the system, and it is not a system property. You cannot say that like a system property, but the generation is always within the system. And number second, the generation will decide the process is reversible or irreversible, or how much the process is extend to irreversible from the reversible one. So entropy generation, if you measure the entropy generation, you can say that how much the process will be deviated, how extent, you cannot say the much, how extent the process is irreversible from the reversible one. So check entropy generation during this process. So you have to find the entropy generation, and also you have to conclude that whether the increase of entropy principle is satisfied or not. What is the increase of entropy principle? What is the increase of entropy principle? My dear, you know that the inverse, that means what is the inverse? In the thermodynamics, how to deal with the inverse? Inverse is nothing, it is an isolated system. So isolated system, entropy must be increased. My dear, locally the entropy may be increased, may be decreased, or remains same. But globally as a whole, that means if you take the system as well as surrounding together, during that one, the entropy must be, entropy generation, that means the entropy of that isolated system must be increased. In the limiting says it may be zero when the process within the system is reversible. Okay. Now, the property it is given, the state point 1, the steam at state point 1, the pressure is 7 megapascal and temperature is 450 degrees centigrade, and that one the enthalpy and entropy, the property it is given, and the state 2, the pressure and the pressure it is given. Now, my dear, you know that for a simple compressible substance, you have to require minimum 2 property to fix the state. So, what is the second? So, P2, from the P2, you cannot just only one property. If you know, you cannot find the another property. You must have a second property. What is the second property? You know that during the throttling, enthalpy at the entry of the throttling is the same as the enthalpy at the exit of throttling. Very important. I am telling you, beta. 99% student confused here कि sir, throttling is an isenthalpy process. It is not like that. It is not necessary that enthalpy will remain constant during the entire throttling process. That means enthalpy at the entry of the throttling is the same as the enthalpy at the exit of the throttling. But it is not necessary that enthalpy throughout the same. So you cannot say ISO. What is mean by ISO? ISO, that means throughout the process it is constant. Isothermal process, that means isenthalpy process. What is the isenthalpy? That means H1 is equal to H2. It is not like that isenthalpy process. H1 at the inlet to the enthalpy and H2 at the exit to the enthalpy, these two are the same. But it is not like that during 1 to 2 the enthalpy is same. So you cannot say that very conclusively कि sir, during the throttling process enthalpy must be constant. But if you find the enthalpy during the vapor compression refrigeration cycle, that means in the one process there is a throttling process we will discuss. During that we have to find the property. If you know the enthalpy at before throttling and after throttling, you can measure all the property. That means you fix the scale, one point and another point, and you have to measure all the parameter. Okay. So it is given. Now, how to start this problem, beta? Anyone please tell me how to start this problem? How to start this problem? Please tell me, anyone. How to start? So let's start this problem. Okay. Let's start this problem. Okay. What is that? Today's problem, let's start this solution throttling process. So, this is your throttling device. This is your throttling device, beta. So, this is your pipe in which the fluid is flowing. Okay, this is your pipe in which the fluid is flowing. And this is your throttling device. This is your throttling device. Yes, this is your throttling device. Yes, this is your throttling device. Okay. This is your throttling device. Okay, you have to restrict the passage. You have to restrict the passage. That means this is your throttling valve. Okay, this is throttling valve. Okay, this is your throttling valve. Now this throttling, that means you have to restrict the passage, and this is your inlet at the throttling. This is your inlet to the throttling. Let's suppose this is your inlet to the throttling. Okay, and this is your exit from the throttling. Okay, so this is your inlet, this is your exit. So this is your I, this is your I, and this is your E, exit. Okay, this is inlet and this is exit. Now, the fluid is entering. That means the inlet condition it is given. What is entry point? Pi, inlet pressure to the throttling, it is given 7 megapascal, 7 megapascal, okay, and Ti, inlet to the inlet, it is your 450 degrees centigrade. This is your temperature at the inlet, it is given, inlet to the throttling, and exit pressure it is given P2, P exit, it is given how much? 3 megapascal. That means pressure must be reduced during the throttling. That means during the throttling, pressure must be reduced. During the throttling, pressure must be reduced. During the throttling, pressure must be reduced. So this is the throttling and pressure must be reduced from inlet to exit. Okay. Hi, Pratik. So during throttling, the pressure must be, that means this pressure Pi is not equal to P exit. That means what is the characteristic of the throttling, beta? Characteristic of the throttling, pressure, that means at inlet pressure, that means at P exit, you can say that must be less than P inlet. This is the first condition of the throttling. And second one is that what is the exit enthalpy is exactly equal to the inlet enthalpy. This is very important thing. These two characteristics, if you know, then you can solve the problem, otherwise very difficult. Okay, now what is about the temperature? Temperature may be increase, temperature may be decrease, and temperature remains same. This is noted point, okay? So it is not like that case temperature will reduce, your pressure will, temperature will increase. It is not like that. It will be, the conclusively you can say that after the experiment, okay? Now, so to find what to find? To find entropy generation, rate of entropy generation. You have to find during this process. Very important, I am telling you, during this process, okay? During this process, you have to find it. Okay, beta? Okay? Now, my dear, since this flow is steady, what is the flow? Flow is steady. What do you mean by the steady? You know that all the property related to the control volume with respect to time is 0. Okay? That means what is the property will change with respect to time are inherent with the time. What is the property related to the control volume will be inherent, that means independent with respect to time. Okay? Now, the second thing is that, see, it is not given like that that throttling is adiabatic or not. But while you have to set up the experiment of this throttling device, you must have to assume like that there is no any heat transfer. Okay? So during the throttling, the other characteristic is that sir, heat transfer, it is 0. Okay? Now, the second one is that there is no any working device. There is no working device. Okay? There is no any working device. That means work transfer, it is equal to 0. So how much the characteristic? P exit is less than P inlet. Enthalpy at exit is equal to enthalpy at inlet. And heat, there is no heat transfer. That means the process is adiabatic and there is no any working device. This 4 parameter is fixed. Okay. Now, this says that steady flow. Steady flow. Flow is steady. When the steady flow, that means what is the change? That means if you take the change of energy of a control volume with respect to time, it is equal to 0. Okay? Entropy change with respect to time of a control volume is equal to 0. This is for the steady. And also you know that this is your stationary device. That means a change in kinetic energy and a change in potential energy is 0. That means delta of kinetic energy and delta of potential energy is approximately 0. Okay? Some students tell that. What is that? Just the student community confusion. What is the confusion is that, sir, if we reduce the area, very important, I'm telling you. So what is the purpose of how to achieve the throttling process? The achievement of a throttling process is only to reduce the area. Now, according to the fluid mechanics, if you reduce the area, velocity must be increased. That is clear. So if the velocity increase, so sir, how we can take the change is equal to 0? Please tell me, anyone. So under what analysis, under what assumptions we can take the kinetic energy change is 0? Why? Because we have to reduce the area, and we know that if we reduce the area, the velocity at exit must be less than the velocity at inlet. We know that. That means change in kinetic energy must be. So how to neglect this one? Please tell me, anyone. So this is fixed. We cannot take the change in kinetic energy. We cannot take a potential energy. But the change, it is 0. How? How the change it is 0? My dear, please note down. We are taking this cross section. This cross section is not exactly at the throttling, it is little bit far from the pipe, and the pipe is uniform. Pipe is uniform. That means what is the velocity at the inlet is the same velocity at the exit. If the cross section is very nearer to the throttling, very nearer to the throttling. Good evening Rahul. Good evening beta. So very near to the throttling, there must be a change in kinetic energy. But under what analysis you can assume that, sir, the exit section is little bit far from that throttling. That means it is at a pipe. So it is inlet to inlet, and it is at exit of the throttling, but inlet and exit both are at the section at the pipe, and at the pipe is uniform. That means at the inlet of the pipe, what is the velocity? At the same as the exit of the pipe from the pipe. So we can take the kinetic energy 0. So the student must be confused here. Sir, why we have to take? Why? Because while you have to perform the practical during the throttling process in your university exam, university colleges. So what is that? You have to reduce the area. So once you have to reduce the area, student confused that, sir, if you reduce the area, velocity must be increased. So you have to be careful. Now, so these are the format of this question. Now, how to start with this question? The start of this question is entropy balance. What is the difference between the energy balance and entropy balance? Anyone tell me? What is the difference between energy balance and entropy balance? Please tell me, anyone. What is the difference between energy balance and entropy balance? Please tell me, beta. Please tell me. Entropy balance. What is the difference between the entropy balance and energy balance? Anyone, please tell me. Anyone? My dear, one thing is very important. See, mass and heat flow. Beta, heat is not flowing. Heat is transfer. Heat transfer. Rahul, you are good. You are absolutely right. Your answer is absolutely correct. But heat is not flow. Heat transfer. Mass is flowing. Okay? So mass will transfer or mass will flow, but heat will transfer. Heat not will flow. Okay? Now, so entropy balance, that means the difference between energy balance and entropy balance is that, sir, the cause of energy transfer, energy transfer is work, heat and mass. But the cause of entropy transfer is only by heat and mass. This is the first difference. Okay. So what is that? Rate of entropy into the system minus rate of entropy exit to the system plus rate of entropy generation is equal to D of entropy, that means change in entropy with respect to time of a control volume. This is your entropy balance. Okay. Now, this entropy transfer, in this case, what is the cause of entropy transfer? In this throttling process, what is the cause of entropy transfer? What is the cause of entropy transfer? So entropy transfer is caused by only mass. Why? Because we have to assume that there is no any heat transfer. So the entropy transfer here only by mass. Clear? Clear? Now, this is 0. This is 0. Why? Because steady flow. Why? Because steady flow. Steady flow. Why? Because steady flow. Clear? So, what is the entropy in due to the mass? So, let's suppose there is a mass flow rate in, and this is a mass flow rate at exit. At exit. Mass flow rate at exit. Now there is a one inlet, one exit. So what is the mass flow rate at inlet? The same mass flow rate at exit. So due to the entropy, due to the mass transfer, what is the entropy transfer? Mass flow rate and specific entropy at inlet minus mass flow rate, specific entropy at exit. Clear? Plus entropy, rate of entropy generation, this is equal to 0. Now, you have to take the mass flow rate is common. So specific entropy at inlet, specific entropy at exit plus S of generation is equal to 0. This is your entropy balance for this system. This is your entropy balance for this system. Okay, this is your entropy balance for this system. Now put all the value. So what is the here entropy generation? Entropy generation is equal to m dot Se minus Si. M dot Se minus Si. So entropy generation, rate of entropy generation is equal to mass flow rate S of exit minus S of inlet. That's it. That's it. Now my dear, there is this question, there is no any mass flow rate. So they say that determine the entropy generation during the process, but there is no any mass flow rate it is given. So you have to better to divide that mass in both sides. That means you have to write like that, S of generation dot m dot is equal to S exit minus S of inlet. S of inlet. Okay. So this is what? Entropy generation. Why? Because this is per second. This is also per second. Per second cancel. So this is entropy generation. Entropy generation is equal to S of exit minus S of inlet. Clear? S of exit minus S of inlet. Now, what is the exit entropy? It is given. Exit entropy at P2 and enthalpy H2 is equal to H1. Exit entropy is 7.0046. 7.0046. 7.0046. Minus, what is inlet entropy? The inlet entropy is 6.6353. 6.6353. 6.6353. If you calculate this one, how much it is, beta? This is your 0.7, this is your 0.3693. 3693 kilojoule per kg Kelvin. This is your entropy generation. So, entropy generation during the throttling process is equal to 0.3693 kilojoule per kg Kelvin. This is your entropy generation. Now, my dear, so this entropy generation 0.6, correct, Rahul. So this entropy generation now, this entropy generation is a greater than 0. Yes or no? So that means this will satisfy the principle of increase in entropy. Why? Because what is the entropy of the generation of the universe? Yeah, isolated system is always greater than equal to 0. This is the principle of increase in entropy. Now, if S generation is greater than 0, that means irreversible process. Irreversible process. Now, my dear, tell me, who is the cause of this generation? Who is the fellow which is responsible to this entropy generation? Anyone please tell me? Who is the cause of this entropy generation? Please, anyone tell me? Rahul? Prateek, anyone tell me? Who is the cause of this entropy generation? This is very important, I am telling you. Who is the cause of this entropy generation? Because of... Please tell me. No. This is generation. See, my dear Rahul, it's a little bit confused. Mass transfer is not a cause of entropy generation. The generation is caused due to the irreversibility. And irreversibility is not a cause of mass transfer. The cause of irreversibility have a two effect. First is the heat transfer for finite temperature difference, and second one is the dissipative effect. So during the throttling process, what is the cause of dissipative effect? The cause of dissipative effect is due to the unrestrained expansion. That means expansion, yes, irreversibility. Yes, this is for the irreversibility. But who is the cause of irreversibility? Very important. If you solve the entropy chapter, must be always remember that, always analyze like that, ki sir, who is the fellow which is generate this entropy? Yes, if there is a generation, there must be irreversibility. The second question is that, who is the cause of this irreversibility? So irreversibility is not caused by the mass. Irreversibility, the cause of irreversibility have a two effect. First is the lack of thermodynamic equilibrium, and second one is the dissipative effect. So this is your dissipative effect. And what kind of dissipative effect? That means expansion against very low pressure. Expansion against very low pressure. If the fluid will expand against a very low pressure, that means unrestrained expansion, that is the cause of irreversibility. That means because of unrestrained expansion. Unrestrained expansion. Entropy generation must be greater than 0. That means expansion against very low pressure. Expansion against very low pressure. Expansion against very low pressure. And this is the category of dissipative effect. So this is your dissipative effect. Effect. Clear? Clear, everyone? Please tell me. Clear? Everyone, please tell me whether it is clear or not. Okay? So I hope this is clear, all of you. Now we have to take the next problem. What is that? Please try to start this problem. This is also the chapter of entropy. What is that? Please read the question carefully. This says that a 50 kg block of iron casting, so this is your iron block casting, at 500 degrees centigrade is thrown into a lake. So it is placed into the lake that is at a temperature of 285 degree Kelvin. The temperature of the lake is 285 Kelvin. The iron block eventually reaches the thermal equilibrium. That means the final temperature of the iron block is equal to 285 Kelvin with the lag. Assume that the average specific heat of the iron, that means this is your C of the iron, it is given. Determine the entropy change of this iron block, entropy change of this lake water, and the entropy generation during this process. That means this says that entropy change of the system indirectly, entropy change of the universe, entropy change of the system, entropy change of the surrounding, and entropy change of the system plus surrounding. They are asking like that. They are asking like that. Okay. Clear? This question is clear? Now start with this one. So, what is that? If you suppose this lake, we know that lake is a tremendous energy resource. That means this is act as a thermal reservoir. This is act as a thermal reservoir. And that thermal reservoir, that means this casting have a high temperature, this lake have a low temperature, there must be a heat flow from that casting to the fluid. That means in this direction there is a heat transfer. That means if you take the casting, it is your system, and lake, it is your surrounding. In between that there is a heat transfer. And that heat transfer is your spontaneous process. That means it is your, and all the spontaneous process is a irreversible process. All the spontaneous process is a irreversible process. So the process is irreversible. Clear? So we have to take this is your one system, lake is your another system, and during that heat will transfer. So how do we have to take this question? Let's suppose this is your iron block. Let's suppose this is your iron block. This is your iron block. Iron. And this iron is your temperature, it is your 500 Kelvin. 500 Kelvin. And let's suppose this is your lake. This is your lake, okay? And lake is your 285 Kelvin. Clear? Now, if you connect these two, automatically the heat will transfer. Heat will transfer. Yes or not? Heat will transfer from the iron block to the lake. Now, so they are asking that what is the entropy change of the iron block? What is the entropy change of the lake? And what is the entropy change of the process? That means if you take these two together, that means total entropy generation. They are asking like that. Okay. So my dear, you have to find the change in entropy. That means to find delta S of iron delta S of lake, okay, delta S of lake, and delta S of system plus surrounding, very important, and delta S of iron plus lake. That means this is nothing, this is your entropy generation. Very important, I'm telling you. That means if you take, that means isolated system will, we already prove in the detailed classes. That means if you take an isolated system, that isolated system is a entropy generation. That means you have always remember this thing with a, that means entropy change, that means S of universe, isolated system is equal to S of generation, and this generation is total. This is very important. This is very important thing I am telling you. Okay. So what is the change in entropy of the iron? What is the change in entropy of the iron? See, iron is an incompressible fluid. Iron, it is your incompressible system. So what is the entropy change of incompressible system? You know that TDS is equal to du plus PdV. You know this thing? Now, this iron block is incompressible, so this dV is equal to 0. Why? Because iron incompressible. Iron incompressible. Okay. So what is that? TdS, and what is U? CV into dt. CV. So for this iron incompressible fluid, CV is equal to incompressible fluid, CV is equal to Cp is equal to C. Specific heat is constant. So you don't bother about that. Ki, sir, here we have to write CV or Cp. We have to write CV or Cp. It is immaterial thing. It is not like that. Okay. So what is that? That means this ds is equal to C dt by T. That means if you integrate it, so this is your delta S C ln T2 by T1. You know this thing. Now, so what is the entropy change of the iron? C of the iron ln T2. Final temperature it is reached at equal to 285. divided by initial temperature is 500 Kelvin. Divide it, find it. Okay. Okay. So beta, this is your specific, and mass of the iron block it is given. Yes or no? Mass of the iron block it is given. So you have always, so this is a specific, this is your specific thing. Small s. This is small s. This is small s. So if you multiply with the capital S, so multiply with the mass. That means if you multiply with mass, so m into delta S is equal to mc ln T2 by T1, and this is your total entropy, delta S of iron. Put the mass. What is the mass? Mass is your 5, and C it is your 0.45. ln T2, final temperature of the iron block, it is equilibrium with the lake 25, divided by T1, 500. So what is this? This is your minus 12.65 kilojoule per kilo. So same idea. It is very important that the system entropy may be increased, may be decreased, or remains constant. So here the system entropy decrease. Now my question is that who is the responsible fellow to reduce this system entropy of the iron? Please tell me in the reply chat box. Who is the responsible fellow to decrease this iron entropy? Please tell me, anyone. Comment in the box. Please comment in the box, beta. Who is the responsible fellow to reduce this entropy of the iron block? Anyone, please? Who is the responsible fellow to reduce this entropy of the iron? Anyone, please? Who is the responsible fellow to reduce this entropy? Why? Because this entropy is, if you calculate, this is negative. Why it is negative? Why it is negative? Who is the responsible? Please tell me, who is the responsible to decrease this entropy of the system? Anyone? Yes. The decrease of this iron block entropy is due to the heat rejection. That means in the iron block, heat will lost. So, for the system, if the heat will loss, the system entropy will decrease. If heat will gain, the entropy will increase. If the system neither heat loss nor heat gain, the system entropy remains constant. Clear? So, due to this heat loss, the entropy of this iron block is reduced. Clear? This is clear? Everyone, please. This is clear? No. Now, my dear, the second question is, what is the entropy change of the lake? What is the entropy change of the lake? How to find the entropy change of the lake? Please tell me, anyone. How to find the entropy change of the lake? Anyone, please comment. How to find the entropy change of the lake? How to find the entropy change of the lake? See, what is the lake? Lake is a thermal reservoir. That means it is act as a sink. It is act as a sink. So if we add the energy to that lake, the lake temperature doesn't change. The lake temperature doesn't change. So how to find? But if you add the energy, lake, though there is a no change in energy, though there is a no change in temperature of the lake, but there must be entropy change. But there must be entropy change. Now, how to find the entropy change of the system whose temperature is constant? Please tell me. How to find the entropy change of the lake and the lake temperature doesn't change? Please tell me, anyone. Please tell me, anyone. See, its temperature doesn't change. So, if its temperature doesn't change, the process is reversible. Yes or not? That means That means if you add the energy, that means the system will take the energy at a constant temperature. That means the process is your latent heat taken. That means this lake is received heat in the form of latent heat, and this iron block lose the heat in the form of sensible heat. Why? Because iron block temperature changes, but the lake temperature is fixed. But the heat, what is the heat quantity that will transfer between the iron block and the lake? The sense is changed. That means in this sense there is a sensible heat, and in this sense there is a latent heat. So if we find the entropy change during the latent heat, and the latent heat transfer is a reversible heat transfer. Latent heat transfer is your reversible heat transfer. Clear? So for this lake, we have to find the entropy change according to the reversible. So what is that reversible? What is that? You know that change in entropy is equal to integration of dq, change in entropy is equal to dq by t plus S generation. Now S generation is 0, so what is the entropy change? Same as the dq by t. Yes or not? See. So for the lake, for lake, that means if this is your lake, 285 Kelvin, and it's take a heat, but its temperature is fixed. That means it's taking in the heat in the form of latent heat. What is in the form of latent heat? So it is a reversible process. Latent heat transfer is a reversible heat process. Now we know that entropy in minus entropy exit plus entropy generation is equal to delta S of lake. Now this is a reversible process, so entropy generation it is 0. Now in this case only entropy in, not entropy exit. Why? Because heat transfer. So this Q by what is the temperature T of the lake plus delta S of the lake. And what is this Q? Q is your latent heat. Now, what is this latent heat value? You don't know. What is the, in this question there is no any given in the latent heat value. So what is the latent heat value? How to find the latent heat value, beta? You know that first law of thermodynamics for process. First law of TD, if you apply for iron block, okay, so for the iron block, what is that? This heat transfer, yeah, this heat transfer, you can say that this heat transfer by the iron block is equal to change in internal energy plus work transfer. Now, iron block is a incompressible, so this is, there is no any work transfer. So what is this one? MC T2 minus T1. This is the heat transfer by the iron. Now, if you put the value of M 50, C 0.45, T2 is 285 minus 500. So this is how much? 4838 kilojoule. And this is negative. Why it is negative? Why? Because heat lost by the iron block. So this is your heat loss. That means this is your iron block. So what is the heat loss? This is the value. Now this heat lost by the iron block is gained by the lake. But this is positive. So here you have to put the heat positive sense. So delta S of the lake is equal to this heat 4838 divided by T of lake, 285. How much it is? Please tell me. How much it is, beta? 16.97. Yes or not? 16.97 kilojoule per Kelvin. Clear? So see, my dear, the entropy change of the lake is positive. Entropy change of the lake is positive. Why? Why? Because it's except the heat. That means this is a positive quantity. So this entropy change must be greater than 0. The change in entropy of the lake is greater than 0. Why? Because it will take a heat. So if it will take a heat but in the reversible manner, so its entropy will increase. So entropy will increase, entropy may be decreased, or entropy remains constant for the locally. That means for a particular system. But if you take system plus surrounding, entropy must be increased. And that increase of entropy is known as entropy generation. Clear? Now, if you find the entropy generation during the process, that means S of total, they are asking that, what do they ask that? They are asking that the entropy generation, that means total, that means S generation total is equal to delta S of the iron plus delta S of lake. That's it. So delta S of the iron, it is minus of 0.6 plus this is your 16.97. How much it is? How much it is? 4.32 kilojoule per Kelvin. Yes or no? So my dear, see, the entropy always increase. The entropy is always increasing. That means it satisfied the principle of increase in entropy. That means if you take iron plus lake as a whole, if you take iron plus lake, this iron plus lake as a whole as a system, this system entropy S of this system entropy, that means if you take iron plus lake of a system entropy, delta S of isolated, that means isolated, this is equal to S of generation, and that is your total. It's always increase. Why? Because it is a spontaneous process. It is your spontaneous process. So, and spontaneous process is a natural process, and the natural process must be irreversible process. So this is irreversible. Clear? Everyone, please. This is clear, beta? This is clear, yes or not? Please tell me. This is clear or not? Please tell me, beta. This is clear or not? Please tell me. This question is clear? Everyone, please. This is clear, beta? This is clear. How to find the entropy of the iron block, how to find the entropy of the lake, and how to find the entropy of the total. Clear? This is clear. Everyone, please tell me. I am requesting you, if you have any confusion, I am telling you, if you have any confusion regarding this chapter, any confusion, any single confusion, I am very happy to reply you. And I am sure that you must be satisfied. It's my challenge, okay? So please feel to ask question, okay? Don't shy, okay? You are not my student or you are my student, doesn't matter. As a teacher, I am very happy to give you very good reply so that you have to satisfy. Your satisfaction is my prime motive. Okay? Your satisfaction is my prime motive. If you satisfy, I am very happy. Okay? So please feel to ask any type of question. Toughest to toughest question. I give you a challenge. I will give you a reply. Very comfortable manner. Okay? Now, so we have to take a third category, that means entropy, and that is your heat exchanger. This is very good question, and I supposed to be asked. It is very much high demandable questions for the GATE 2024. Okay, so this is very good question, okay. Now, so intuitionally, this question I will take for what that, why, because this type of question right now they are not asking, okay. So this is the heat exchanger, and you know that as a mechanical engineer, you must be know about the what is the heat exchanger, okay. So you know that all the things. Okay, first tell me, heat exchanger is an adiabatic device or non-adiabatic device? Please tell me. Heat exchanger is an adiabatic device or a non-adiabatic device? Please tell me. Heat exchanger is an adiabatic device or a non-adiabatic device? Please tell me. Anyone, please. If you know this thing, that is a very basic question. This is your very basic level question, okay. So this is your very basic question. You must have a know about this thing, okay. So what is the heat exchanger? Heat exchanger, first tell me, it is a device, heat transfer device, and but the heat exchanger is an adiabatic device. If you consider the analysis of heat exchanger, it is an adiabatic device or non-adiabatic device, okay. Please think and write the comment box, okay, no problem. So this is your heat exchanger, one cell, 4 tube pass, no problem. This is adiabatic. Very good, Rahul. Adiabatic device. Heat exchanger is an adiabatic device. Very good. Your concept is good, okay. So in that one there is air is flowing. That means at this section air is in at a 20 degree centigrade and air is exit at a 30 degree centigrade. That means this air, it is a cooling fluid. It is your cold liquid, cold fluid. Why? Because why cold? Why? Because it is heat. After taking a heat, that means air will take heat and steam will lose heat. So steam is a high temperature fluid and air is a low temperature fluid, okay. So air is a cold fluid and steam is a hot fluid. So this steam at point 1, hot fluid inlet and hot fluid exit. Hot fluid inlet, hot fluid exit, and the air, cold fluid inlet temperature and cold fluid exit temperature it is given, okay. Now, so air in a large building is kept warm. What is the purpose of practical application of this one? To warm the building room, such type of heat exchanger. With a steam in a heat exchanger, so this is your steam, saturated water vapor. That means what is the saturated water vapor? That means the dryness fraction is 1. Saturated water vapor enter this unit at 35 degrees centigrade, okay, at a rate of 10,000 kg per hour, okay, and leave the saturated liquid. What is the dryness fraction of saturated liquid? 0. So dryness fraction 1, the fluid is in, and dryness fraction of 0, fluid is out. So this is a hot fluid in and the hot fluid exit. And what is the temperature? 32 degrees centigrade, okay. Air at 1 atmospheric pressure, this is 1 atmospheric pressure, that means pressure doesn't matter. Air at 1 atmospheric pressure enters the unit at 20 degrees centigrade and leaves at 30 degrees centigrade. Why? Because air acts an ideal gas, so it's have a constant phase, it doesn't phase will change. And at about the same pressure, okay, that means what is the pressure at inlet? The same pressure at exit. That means pressure doesn't much more play the role while studying the heat exchanger. You know this thing, okay. Determine the rate of entropy generation associated with this process. That means you have to find the entropy generation during this process. Now the property it is given in the question, the steam. Why? Because steam phase will change. First it is a saturated vapor and then there is a saturated liquid. So it's changing the phase. So while the changing of the phase, its property it is given, saturated vapor, enthalpy, saturated entropy it is given, saturated liquid enthalpy it is given, saturated liquid entropy it is given. And they are asking that what is the entropy change generation of this process, okay. Clear? Question is clear, beta? Question clear? This question is clear, please tell me. Is there anything you have to want to discuss in this question? Please feel to ask me. Is there anything you want to discuss these questions, or we go further for the solution? Anyone, please? This is clear? This question is clear? Everyone, please tell me. Reply in the chat box. This question is clear? Yeah, anything you want to discuss with this question? Okay. Thank you. So, what is that? This is your... So, we have to start with this one. So, this is your heat exchanger. Okay. Let's suppose this is your inner tube. This is your inner tube. Okay. This is your inner tube. And this is your outer tube. This is your outer tube beta. Let's suppose this is your inner tube. This is your outer tube. Okay. And outer. Hi Sami. Hello. Very good evening. You are late in the class. You are late in the class. You join the classes late. Okay. Don't repeat again. Okay. Class as a 6 o'clock. So must be present at a 6 o'clock. Okay. Why? Because I know you are the very good student. Okay. Thank you. Thank you. Thank you. Thank you. So this is your tube. That means a heat exchanger. It is a kind of heat transfer to warm the building. So generally outside of the heat exchanger have a cold fluid, and inside the tube there is a hot fluid. Okay. So what is the hot fluid? Steam. What is the hot fluid? Steam. So this is your inlet section. This is your inlet section, and this is your exit section. Here. This is your inlet section, and this is your exit section. Now, my dear, this is your hot fluid, and this is your cold fluid. Hot fluid in, thank you. Hot fluid in, okay. Hot fluid in, it is your saturated vapor, okay. Hot fluid exit, saturated liquid. In the question, this is given. Saturated vapor, dryness fraction 1, saturated liquid, dryness fraction 0. And the property it is given. The property it is given, hot fluid, what is the inlet temperature and exit temperature is given. And now, my dear, you must be very much clear about that. During the heat transfer, due to the heat exchanger, the pressure drop is very, very minimum. So you don't bother about what is the pressure drop. Yes, some students get confused here. Sir, while the fluid is flowing through a tube, a pipe, the pressure must be reduced. But that analysis is the fluid mechanics analysis. We are not analysis the fluid mechanics point of view. We are analysis as a thermodynamics point of view. So what is the heat exchanger that will transfer the heat? We don't bother about that. What is the pressure drop? What is that thing? Okay, don't bother about that. Now the cold fluid, cold fluid is air, and hot fluid, it is your steam. Okay, so air temperature inlet and exit given, hot fluid inlet and exit temperature given, and they are saying that what is the entropy generation during this process? That means while the heat will transfer, what is the heat transfer? Hot fluid to the cold fluid. This heat will transfer hot fluid to the cold fluid. So during the transfer of heat, what is the entropy generation? That means you have to find that entropy generation, entropy generation during this process. Now, my dear, I already told you when you have defined the entropy generation during the process, that means that is a total entropy generation. That means this is your S generation total. You have to find the S generation total entropy generation. Okay. Now, so this total entropy generation is equal to the entropy generation internally. You know this thing, all this thing. If you have a basic knowledge, you can play with this. Okay, that is the chapter is very easy, but the concept is very powerful. If you know the concept, the chapter is very easy. Okay. So first, entropy balance. Entropy balance for heat exchanger device. Okay, what is the entropy balance? What is the entropy balance? Entropy in, rate of entropy in minus rate of entropy exit plus rate of entropy generation is equal to delta S CV by dt. Now, my dear, you can tell me, you can ask me one question. Sir, this entropy generation, what is the physical significance of this entropy generation? Why we have to add the entropy generation with the entropy transfer? See, there is a bank. In that bank, you have deposited some money, SI. After some time, in the bank, you have to withdraw some money, SE. During the process, the bank gives your interest. So interest will add you. So it will be addition form. Why the entropy generation is adding this entropy transfer? Why? Because, see, there is a bank. If we are depositing some money, after some time, we are withdraw some money. During that process, bank gives the interest. So interest kind of nothing, it is a generation. Okay? That is the simple things. Okay? So this is the generation. Now, this system is steady. Yes or not? This system is steady. Why? Because what is the flow is in same fluid. So for the system steady, this is 0. Why? Because steady device. Steady device. Okay? Clear? Now, what is the entropy in? What is the responsible? So this entropy transfer in or out, who is the responsible fellow? Here, please tell me. Who is the responsible fellow to transfer the entropy? Rahul, Sami, Pratik, everyone please tell me, who is the responsible fellow to transfer this entropy? In this question, who is the fellow to transfer this entropy? You know that entropy transfer is due to heat and mass. So who is the fellow to transfer this entropy? Option number first, heat only. Option number second, mass only. No, Rahul, you are wrong. That is the main beauty. That's why I'm asking. If that question is very, if my question this question is very easy, I'm never ask you. The entropy transfer is here mass only. Why? Because we have to find the entropy generation total. That means we have to take this total as a system, and this system is adiabatic. This system is adiabatic. So this entropy transfer due to mass only. That is the beauty. That is the beauty of this question. Why? Because we have to find the entropy generation total. So this is your total. Okay, this is your total. So if you take total, that means a heat exchanger, and you know that heat exchanger is non-adiabatic. So heat exchanger is adiabatic. Sorry, heat exchanger is adiabatic, and during the adiabatic system, it is not any at all for the responsible of heat transfer. So who is the fellow which is responsible to heat transfer? That fellow is mass only. Clear, Rahul? Rahul, it is clear, beta? Please tell me. Rahul, it is clear? But between the pipe, that is the main things. Why you are, see, that is the very important thing. You are asking very important. We are not between. We are finding the heat exchanger. See, read this question carefully. We have to find, see, determine the rate of entropy generation associated with this process. That means this fluid will transfer and this fluid will transfer. That means we are taking. So see very carefully in the entropy chapter, if it is written like that, entropy generation associated with process. Entropy generation associated with this process. Entropy, it is not asking that entropy generation of the steam. It is not asking that entropy generation of the air. It is asking that entropy generation of the process. So if there is a process, that means total. And if you take a total, that means this is our system. If this is our system, there is no any chance of heat transfer from this system to the surrounding. Why? Because this is the adiabatic system. Clear, Rahul? Clear, Rahul? If you find the heat between the heat transfer, that is the entropy generation, either steam or air. But we are not bothering about what is the entropy generation of the steam and what is the entropy generation of the air. We are bothering about the entropy generation associated with this process. That means total. That is the language. Clear, Rahul? Rahul, beta, it is clear. Everyone, please tell me. If you have any confusion, please ask me. Okay. So mass only. So let's suppose steam. Entry is the steam. This is your steam in. Steam in. This is steam exit. This is air in. This is air exit. So this in, according to this question, this in is 1 and exit is 2. That means this is a point 1. This is point 2. And entry it is 3. And this entry it is 4. It is like that. It is given. Labeling it is given. See. Air entry is 3. Air exit is 4. Steam entry is 1. Steam exit is 2. So we are labeling this. Now, so S in. What is the S in? Here, what is the S in, beta? Please tell me. S in due to the mass. So mass only. Mass. Let's suppose mass flow rate of steam into SI. 1. Let's suppose this is 1. Okay. What is in here? Air. Mass flow rate of air. In is, air in is S3. S3. So this is in. So this follow, it is in. Now minus what is out? Out is saturated liquid. Saturated liquid. So mass flow rate. Mass flow rate is same. Mass flow rate of saturated liquid or a mass and mass flow rate of the steam is same. Mass flow rate of air entry is same as the mass flow rate of air exit. So mass flow rate of steam. So mass flow rate of the saturated steam, yeah, mass flow rate of saturated liquid are same. Doesn't matter. So this is simply we have to write mass flow rate of steam. Steam exit into S2 plus mass flow rate of air into S4. So this is clear? Is equal to plus mass flow. Mass flow. Yes, correct. Is equal to plus S of generation total. This is clear? Please tell me. Rahul, this is clear with everyone. Please tell me. This is clear or not? This equation is clear or not? Please tell me. This is clear or not? Please tell me, everyone. This is clear or not? Please tell me. This is clear or not? Please tell me, everyone. This is clear or not? Please tell me, everyone. This is at entry fluid and this is your exit fluid. Okay, thank you. Now, so what is the S generation? If you solve this one, what is the S generation now? So S generation, you have to take this steam and steam common. You have to take this mass of air and mass of air is common. So S generation total is equal to mass flow rate of steam into S2 minus S1 plus mass flow rate of air into S4 minus S3. Clear? Clear? Now, the second thing is that mass flow rate of steam, it is given. Yes or not? It is given. But mass flow rate of air, it is not given. Yes or no? Mass flow rate of air, it is not given. How to find the mass flow rate of air? That is the very important thing. How to find the mass flow rate of air? See in the question. Mass flow rate of steam, it is given. But mass flow rate of air, it is not given. Okay, no problem at all. Now, entropy, steam, this S2 is what? Saturated liquid. Saturated liquid. What is S1? Saturated vapor. And these two are given. And this is also given. S4 and S3, it is given or not? No, it is not given. So we have to find this fellow. And this is for ideal gas, air. Clear? Now, many students get stuck here. That is the simple thing. This is the simple thing. This is the format of the question. Now, the final equation, that is the pure hardcore of thermodynamics. Now, what is the mass flow rate of steam? This is equal to 1/10,000. This is kg per hour divided by 3600. So what is this one? This one is your 2.77 kg per second. So you know that this mass flow rate. Now, how to find mass flow rate of air, beta? Please, anyone give reply in the chat box. How to find mass flow rate? I want to your reply. Everyone. How to find the mass flow rate of this air? Mass flow rate of this air. How to find mass flow rate of this air, please? How to find, see, mass flow rate of the steam, it is given. How much it is? 10,000. So it is converted into kg. Second, it will be okay. Now, what is the mass flow rate of this air? What is the mass flow rate of this air? Mass balance. How to? No, not mass balance. Wrong. Rahul, you are wrong. Energy balance. Not balance. How to find the mass balance of this air? No, not how to find. Mass of air in minus mass of air out is equal to change in mass of the air. There is no any meaning. If you say that mass balance, it is no any meaning here. What is the mass balance? Mass transfer in, mass flow rate at in, या mass in minus mass of exit is equal to mass of change in mass of a control volume. So mass in and mass exit are same. So it is not like that. That is the beauty. To find the mass flow rate must be applied the energy balance within this hot fluid and cold fluid. So my dear, we know that what is the energy will transfer by the steam, that all the heat will taken by the cold fluid. Yes or not? Yes or not? See, what is the heat will transfer? What is the heat will transfer by the hot fluid? What is the heat will transfer by the hot fluid is heat taken by the cold fluid. You have to balance it. And therefore, you have to find the mass transfer. So, you have to find the mass transfer, must we follow the energy balance. To find mass transfer of air. So, energy balance. Energy balance between hot and cold fluid. Hot and cold fluid, what is that? Heat transfer by the steam is equal to heat taken by the air. That's it. Why? Because it is steady. Now, So what is the heat transfer by the steam? Now, what is the heat transfer by the steam, beta? What is the heat transfer by the steam? Please tell me. Heat transfer by the steam. So in the pipe there is a heat transfer. In the pipe there is a, see, this is your pipe. In this pipe, this is your steam. This is your steam. And this steam will transfer heat. So how to find this heat transfer? Steady flow energy equation. Steady flow energy equation. So what is this? This is your inlet and this is your exit. So what is the heat transfer by the steam is equal to, this is at a constant pressure. This is at a constant pressure. So constant pressure heat transfer is what? Change in enthalpy. So m dot into H exit minus Hi. Change in enthalpy, m dot into H exit. Now you have, now from here, you have, this is your steam. So from this one, you can easily find mass flow rate you have. So you can find heat transfer by the steam. How much? This is your 2.77 into exit enthalpy. How much the exit enthalpy? This is your saturated. This is saturated liquid and this is your saturated vapor. Saturated liquid enthalpy it is given. Saturated vapor enthalpy it is given. So saturated liquid enthalpy is how much? Saturated liquid enthalpy it is. Saturated liquid enthalpy it is 134.1. Saturated vapor enthalpy it is 256.2564.6. Please put it. That means 134.1 minus 2564.6. Put this value. So heat transfer it is your 6751 kilowatt, and obviously this is negative. Why? Because it is heat loss. And this, now if you find heat transfer by the air, heat transfer by the air, so this is positive. So put this value 6751 kilowatt. Okay. And what is that? So this is your what? How to find? How to write this one? Okay. Negative. Yes. 67. 6751. 6751 beta. Okay. Now, what is this energy equation for the air? What is the energy equation? What is the heat transfer for the air? How to write? This is the heat transfer from the steam. Steam changing phase. Air will take a heat, but it is a constant phase. How to find the heat transfer of the air? Heat transfer by the air is equal to mass flow rate of the air, Cp of the air into T exit minus T inlet. Yes or not? M. Why? Because it is a change in internal energy. That means what is the heat will taken by the air? That air will increase its internal energy, so its internal energy increase. So this air heat transfer, heat taken by the air is equal to the heat lost by the steam. Cp of the air you have 1.005, that means 1. T exit you have, T inlet you have. So from here you can easily find mass transfer of the air. This is what? 6751 and Cp of the air is 1. Let's suppose this is 1.005. Yeah, 1. Exit temperature it is 30. It is given minus 20. So how much it is? 67.7 kg per second. This is your mass flow rate of air. It is clear to everyone? Please tell me. Reply in the chat. This is clear? How to find? So steam will change its phase. So M STHE minus HI. It will take in heat, but it is your internal energy. That means what is the phase change? That means this is changing its phase. So change its phase, enthalpy of the saturated liquid minus enthalpy of the saturated vapor. Clear? So this is your mass of the air. Now put the mass of the air. Now the second task is that how to find the entropy change of S4 minus S3. Please tell me. This is given. This is given. How to find S4 minus S3 for ideal gas? What is the change in entropy? What is the change in entropy, beta? What is the change in entropy? Delta S. You know that Cp ln T2 by T1 minus R ln P2 by P1. You know this formula? Yes or not, everyone, please? You know this formula, beta? Rahul, you know this formula? Cp ln T2 by T1 minus R ln P2 by P1. Ideal gas. Ideal gas. Cp ln T2 by T1 minus R ln P2 by P1. You know this thing? Okay. Now, this is for the ideal gas. You have to find very easily from the TDS equation. TDS equal to du plus dH minus VdP. dq, that means TDS equation. Okay. So, P2 minus, so during the flow, there is a constant pressure. So this is 0. So what is the delta S? Delta S is what, beta? S4 minus S3. S4 minus S3. This is a specific. Multiply with the mass. Multiply with the mass. So mass of air. Cp of air, ln. Final temperature is what? T4. Initial temperature is T3. Why? Because exit air at a 4, entry air at a 3. So T4 minus T3. Why we have to multiply with mass? Mass, why we have to take a specific? Why? Because there is a specific. You have to find a specific, multiply with the mass. So you have a mass of air, you have a Cp of air, you have ln T4 by T3. Put all this value. So S4 minus S3 you have. Put this value here, mass of the air, all the things you have to put. Thank you, Subodh. Thank you. Okay. Put this value here. That means mass of the air, Cp of the air, ln T4 by T3. Put here. Mass of the air you have from the ideal gas. Increase internal energy. Okay. Good evening, Manish. Good evening, beta. Good evening. Good evening. So mass of the air you have. Okay. Entropy change you have. Put all this value. Find the answer. Total entropy generation. That means S generation during this process total. Calculate it. Please calculate it, beta. If you calculate, the answer is 0.745. 0.745 kilojoule per kilo. It is in kilowatt. Please check it. If you have any confusion regarding this one, please feel free to ask. I give you 2-minute time. Please feel free to ask. Anyone, if you have any type of confusion, don't shy, please ask. Okay? These questions for the heat exchanger, this is more expected question in the 2024 upcoming GATE exam. Okay? So don't take it for granted. Okay? So if you have any confusion, please feel free to ask. If you have any confusion, please, I request you, please feel free to ask me any type of question. Okay? Okay, so I hope you are clear now. Now we have to go to the next problem. The next problem also related to the term entropy, but that is also very good problem. So anyone please, I give you option. This question is, what is your categories? What do you think? This question is tough, moderate or easy with respect to you? Please, this question is tough, moderate or easy? Please tell me. According to you, this question is tough, moderate or easy? In your exam, if you read this question, this type of question, what's your analysis? Sir, this question is tough, moderate or easy? Please reply in the comment box. Please reply in the comment box. This question is tough, moderate or easy? Please reply in the comment box. This question is tough, moderate or easy? Moderate. Great. But my point of view, this question is little bit tough. My point of view. Okay. But that is the moderate. That is a very good thing. Okay. Why? Because many things involved. How to find the heat transfer for the phase change, how to find the heat transfer for the ideal one, how to find the mass transfer, how to find the entropy, how to apply the energy balance, what is the heat exchanger, what is the analysis during the analysis of heat exchanger, what is the assumptions. All these things are in a single questions. Okay. So that my point of view, this question is more tough. But if you feel like that this is moderate, I'm very happy. Okay. Now, so we go to the next problem. The next problem is like that. Please read this question carefully. Before going to the next problem, same thing is that I will just inform you. The IMS provides some features to you. The IMS provide, what is the program feature of the IMS? This is the very important things. Please convey to the another student also. We have provided to 800 plus hour of the live classes. That is very important. With the live interaction. Number second, theory book. We have a separate theory book. We have a separate exercise book. And we have a separate PYQ of 30 plus year. That PYQ includes 30 plus year. And what is the uniqueness of this PYQ, beta? This PYQ have a two unique things from all other. If you compare with the other platform of the PYQ, that PYQ, what is the difference? Why you have to bother about this PYQ? Why you have to take this PYQ? Why you have to buy this PYQ? That is the question. The answer is that this PYQ have a video solution. Number first, all the toughest question have a video solution. Just you scan it, you have a directly link to the video solution. Number second, which is very important, approximately 70 to 80% of the toughest problem, minimum two solution is there. First solution and second solution. That is the two things which we will be separate this book from the all other platform of the book of the PYQ. Number second. Number third, 12 one-to-one session in a year. In a month, there are 12 one-to-one personalized session. That means you have to directly go to the particular faculty and ask anything what you have to want to ask. Anything, personal, one-to-one session. And along with that, 130 plus online test series. And the test series have a 4-5 categories. First, chapters test. Second, subject test. Third, mix of 2-3 subject. Fourth, mix of 3-4-5 subject. And all the subjects add together have an advanced test. So these are the uniques. If you know the more information regarding this one, you feel free to call this number. Okay? You feel free to call. There is nothing is worry about that. Now, the second one, if you want to know the more information regarding this one, sir, how to download the notes of this today's class, how to find the, how to know that, what is the update for the next upcoming sessions, yeah, who is the taking session, who is the faculty who is taking the sessions, and what is the subject that next session we'll discuss. That all are the information are given in this Telegram group. So you must have to join this Telegram group, and this Telegram group has a unique feature: schedule of YouTube lectures, lecture PDF, important updates related to the seminar, webinar, and also other notification, and also expert session to the important topic. That means expert session online on the important session, and also daily quiz. This is very important. Last one is a very important. Daily quiz is there. Okay, these are the some information. Now the next one is, okay, the next one is the next question. Please read this question carefully. Please read this question carefully. This is your piston cylinder arrangement. In that one, there is a saturated, there is a fluid is there, and that fluid is changing its phase. That means a frictionless piston cylinder device contains a saturated liquid water vapor mixture. That means there is a saturated liquid and saturated vapor mixture is there of water at what temperature? 100 degrees centigrade. That means this fluid which is inside the piston cylinder arrangement have a temperature 100 degrees centigrade. Okay. During the constant pressure process, that means we have to take the process as a constant pressure process, 600 kilojoule of heat is transferred to the surrounding air at 25 degrees centigrade. That means if you follow the process at a constant pressure process, this system, that means this reddish dotted line system, transfer the heat to the surrounding at a magnitude of 600 kilojoule to the surrounding, and the surrounding temperature it is given 25 degrees centigrade. As the result, part of the water, that means if the this is the saturated, let's suppose you don't think much more. This is the vapor. This is your vapor, and in the vapor it is placed inside the cylinder, and after a while the temperature of the vapor is higher than the surrounding. There must be a heat transfer. That is the simple funda. During the heat transfer, some of the vapor will condense. Yes or not? Yes. If there is a vapor have a high temperature contact with the low temperature, vapor this is the understable that it will condense. So it will condense, and this is your condensed liquid. This is your condensed liquid, and this is your vaporized fluid. Okay. Now determine what you have to find that. Determine the entropy change of the water and the total entropy generation during this heat transfer. Total entropy generation during this heat transfer. Please. The question is clear, beta? Everyone, please. This question is clear? This question is clear? Everyone, please. This question is clear, beta? Everyone? Okay. Now we have to go further. Okay. What is that? See this one. 0.37. 0.37. What is that? Entropy generation. Which one answer, beta? Which point A? Which option? Manish, which option, beta? Papa, which option? Papa Ji, which option? A, the entropy change of the water. Which option you have to say that 0.37? Please reply in the comment box. Which option? Entropy change of water or entropy generation during the process? Which option it is? Okay, let's see the further. So, there is a piston cylinder arrangement. Okay. 2.63. Which is one? 2.63. Which one with a option? Please write the option. 0.37 option A. Matlab what? Which question? Option question number A or question number B? Yeah, 2.63 question number A or question number B? Question number A, entropy change of water. Question number B, A, 0.37. Wrong. A, 0.37. Wrong, beta. A, entropy change of the water. Wrong. B, entropy change of the during this process. Also wrong. Both are wrong. Both are wrong. Okay. So this is your piston cylinder arrangement. Okay, this is as a piston. This is a piston. In this piston, this is a piston. Okay, this piston, and there is a water. Water is there, and this is your vapor. And this water and vapor have a temperature 100 degrees centigrade. Okay, it loses heat. It loses heat. That is your 600 kilojoule at a temperature of surrounding 25 degrees centigrade. I think so. It is given. Okay. So we have to find number A, entropy change of water option B, entropy, that means total entropy generation. Entropy generation. Okay, now see beta, what is that in this one? What is the question in this one, beta? See, during the condensation, that means this is your condensation. During the condensation, which type of heat transfer will take place? The type of heat transfer will take place is the latent heat. And this latent heat transfer okay, that is the latent heat transfer, and during the latent heat transfer, this is at a constant pressure, so there must be a reversible process. So this heat, during this process, what is the heat transfer will take place? That is your condensing heat transfer. That means it will condense. That means this is your latent heat transfer, and that latent heat transfer due to the reversible process, that means there is no any irreversibility within the system. Number first, there is no any irreversibility within the system. Now, but the irreversibility outer system is there. Why? Because this heat transfer across a finite temperature difference. Finite. So this is your external irreversible and internal reversible example. This line is clear now. Please tell me. This is clear not, कि sir, this is the situation of internal reversible and external irreversible. This is clear not? Please tell me. This line is clear not. See, this is not a kind of to solve the question. The questions in the thermodynamics, the approach is very clear. Otherwise, you have to very high chance to mistake. This is the example of this question is the example of internal reversible but external irreversible. This is clear not? Please tell me. This is clear not? Why? Because this heat will transfer at a constant temperature. So during the constant temperature, this constant temperature, that will condensation. And this is at a constant pressure and constant temperature. So internally there must be a reversible. But this will take a heat to the surrounding and system have a finite temperature difference. So this is your lack of thermodynamic equilibrium, but it is not lack of dissipative effect. That means internal reversible, that means this is the example of internal reversible plus external irreversible. This is clear not, beta? Please tell me. This is clear not? Please tell me. Everyone, please tell me. This is clear not? Clear. So, internal reversible is what? There is a water. Why? Because this says that entropy change of water. So, for the water entropy change, this is your heat transfer divided by T of this system. not system, system boundary. More precisely, you have to take the system boundary temperature. Oh, this is your system boundary temperature. T of boundary. What is that heat transfer? This heat is loss from with respect to this system. This is negative. So minus of 600. What is the boundary temperature? 100 degrees centigrade plus 273. 100 plus 273. What is this value? This value is minus 1.61 kilojoule per kg. Clear? The first one is clear, beta. Everyone please tell me. This first one is clear. Entropy change of water. Why we have to write this equation? And this heat is a nothing. It is a latent heat. This is your latent heat. It is clear? Now, we have to find the entropy, total entropy generation. So balance it. What is that? Entropy balance. What is the entropy balance? Rate of entropy in, that means not rate basis, S in minus S exit plus S of generation is equal to delta S of the system. Clear? Now we have to find the total, so we have to write a total. So if we write the total, this system is a total. That means system plus surrounding. So this system is system plus surrounding. That means system plus surrounding. If you take the system plus surrounding, the temperature is must be a surrounding. Previous question. So there is no entropy in. Why? Because during the total only entropy exit. So there is no entropy in. Here it is not entropy. Why? Because entropy exit is there. So this is 0 minus entropy exit is Q out divided by, now T is what temperature here? If you write total, so T is surrounding plus delta S of plus S generation plus S generation total plus S generation total plus delta S of the system is equal to, if you write total, this is your system. Okay. Once again, this is very complicated here. We'll write in the next page, no problem. Okay. So entropy balance. Okay. And this entropy balance is caused due to the heat transfer. What is that? Entropy in, entropy exit, S of generation plus delta S of system. And you know the delta S of the system. If you apply the system, so my dear, there is no any entropy in minus of, what is the entropy? This is for the surrounding. So if you put entropy generation here, so minus of Q divided by T of surrounding, this is your S of generation, and this S generation is total. So if you write surrounding temperature, you must be write the total, and this is your delta S of system. Clear? Now, so what is the S of total? Q by T of surrounding plus delta S of system. Okay. Now what is Q? So S generation total is equal to Q, it is your 600 divided by surrounding, it is your 25 plus 273 plus delta S of the system is minus 1.61. If you put this value, this is a 0.4 kilojoule per kg. So this is entropy generation. Okay, it is clear. Now my question is that what is the entropy generation of the water? In this question, if they are asking that the entropy change of the water, option first, second, entropy generation of the water, options, question number C, option, question number D, total entropy generation during the process. What is the entropy generation of the water, beta? Anyone please comment. What is the entropy generation of the water? What is the entropy generation of the water? What is the entropy generation of the water? Please tell me, what is the entropy generation of the water? Entropy generation of the water is 0. Entropy generation of the water is 0. Why? Because water have a phase changing. And during the phase changing, latent heat is there. And latent heat is, right, internal reversible. So internal reversible, there is no entropy generation of the water. Now, but entropy generation of the surrounding is there. Why? Because it will take the heat transfer for a finite temperature difference. That means, who is the responsible fellow to generate this entropy, beta? Who is the responsible fellow to generate this entropy? Please tell me. Who is the responsible fellow to generate this entropy? Who is the responsible fellow to generate this entropy? The generation of this entropy is due to finite lack of thermal equilibrium. Lack of thermal equilibrium. Why? Because heat transfer takes place of a finite temperature difference. See, 125. So this heat transfer caused the entropy generation total, but the entropy generation of this fluid internally is 0. Why? Because internal is reversible and external is irreversible. So internal is reversible and external is reversible. So what is the total? Total is irreversible. Total is irreversible. And this total irreversibility is caused by the lack of thermal equilibrium. Why? Because heat transfer takes place through a finite temperature difference. Clear? Everyone please. This is clear, beta? This is clear, everyone please tell me. This is clear, everyone please tell me. Is there any confusion? Please ask. Is there any confusion? Please ask, beta. Any confusion? Please ask. Is there any confusion? Please ask in this question related to why this question is also important. There is any confusion? Clear. Okay, clear. Now, so this is clear. The next one is this question. Let's try to solve this question. Please try to solve this question. So there is a adiabatic vortex tube. This is your adiabatic vortex tube. There is a T joint. There is a T joint, and this is your adiabatic. That means there is no any chance of heat transfer. Inlet. This is point 1. This is point 1. This is point 1. It is inlet at a high pressure air in, and low pressure will out. This is your in. From this joint, this two type of the fluid is flowing. Both are the low pressure, but this is your hot and this is your cold. So this is your 1, let's suppose this is your 2 and this is your 3. Clear? Clear? Now what is this question? It says that an adiabatic vortex tube shown in figure given below is supplied with 5 kg per second of air at inlet 1 at 500 kilopascal and 300 Kelvin. Two separate streams of air are leaving the device from outlet 2 and 3. Clear? Hot air leaves the device at a rate of 3 kg per second from the outlet 2 and at 100 kilopascal and 340 Kelvin, while 2 kg of cold air stream is leaving the device from the outlet 3 at 100 kilopascal and 240 Kelvin. Clear? Consider constant specific heat of the air, that means Cp 1005 joule. This is joule. So kilojoule 1.005 joule per kg Kelvin, and the gas constant R value. This is a characteristic gas constant, it is given. There is no any work transfer, and also there is no any heat transfer. Why? Because this is adiabatic. This is adiabatic. Okay. The rate of entropy generation. See, the rate of entropy generation during this process. What is the entropy generation during this process? Please find it. What is the entropy generation during this process? This is a very good question also. What is the entropy generation during this process, beta? Please, everyone. Question is clear? Everyone, please. This question is clear, beta? This question is clear? This question is clear? Please tell everyone. This is clear, everyone. Please tell me. Reply in the comment. There is any problem in this question? This question is clear. Please, everyone, reply in the comment box. Okay. So we have to go to the next. So this is the question. I will just write the information. So this is your tubes, vortex tube, adiabatic vortex tube is there. Okay. So there is a adiabatic vortex tube is there. Okay, just take adiabatic vortex tube is there. Okay. Okay, this is adiabatic vortex tube. Clear? Now, it is given, so there is an inlet exit condition given. So we have to take the control volume like that. Okay. So we have to take control volume like that. So this is a control volume. We have to take, this is our control volume. This is our control volume. Okay. Here is in. Here is in high pressure air in. This is low pressure out. This is low pressure out. But this is your inlet. This is your inlet. It is given mass. This is 1 point. This is 2 point. Section 2. And this is section 3. It is given. Mass flow rate at 1 point. It is given beta This is your 5 kg per second. Temperature at 1 it is given 300 Kelvin. Pressure at 1 it is given 500 kilopascal. Clear? 3 point, this is your hot air. This is your hot air, and the property it is given. Mass flow rate at 2 it is your 3 kg per second. Pressure it is given 100 kilopascal. Temperature T2 it is given 340 Kelvin. This is cold air. Cold air. And the cold air, obviously this is mass flow rate 5, so this is 3, so this is 2. Mass flow rate at 3 is 2 kg per second. T3 it is given 100 kilopascal. T3 is given 240 Kelvin. This is given. Okay. Cp of the air it is given. Cp of the air it is given. R value it is given. So Cp of the air it is given 1005 joule per kg Kelvin it is given. R value given 287 joule per kg Kelvin it is given. There is no heat transfer. There is no work transfer. These are the information. Clear? These are the information it is given. Now, how to start with this one, Tal? How to start? Please, everyone. Please, everyone. How to start? How to start this question? Please, everyone. This is the question related to all the balance, mass balance, energy balance, and entropy balance. Okay? So, we have to start entropy balance. What is the entropy balance? What is the entropy balance, beta? S in rate of entropy in minus rate of entropy exit plus rate of entropy generation ds by dt of a control volume. Now this already told that an adiabatic vortex tube, and these are the steady device. What is the in? 1.06. What is the 1.06? Answer. No, it is wrong. What is the 1.06 beta? S generation? No, wrong. 1.06 wrong. Please check it. So this is adiabatic, so it is 0. Why? Because steady device. Okay. Now, in this case, who is the responsible this entropy transfer? In this case, who is the responsible this entropy transfer? Please tell me. Who is the responsible to transfer this entropy? Only mass. Only mass. Why? Because there is no any heat transfer. Okay. So mass is in. So in is about mass in. So mass flow rate at 1 is 1. This is your inlet. Minus of exit. Exit is m dot 2 s2 plus m dot of 3 s3. This is your exit. Clear? Yes. Very good, Rahul. Mass. Exit. Plus S of generation is equal to 0. So what is the S of generation? S of rate of entropy generation is what? M2 dot S2 plus M3 dot S3 minus M1 dot S1. Is there any problem at this stage, beta? Please tell me. Is there any problem at this stage? Please tell me, everyone. Is there any problem at this stage? Please tell me. This is the required entropy balance for the system. Is there any problem at this stage? Please tell me. Is there any problem at this stage? Please tell me. Is there any problem at this stage? Please tell me. No. Very good. Now, and what is the mass balance? What is the mass balance? Mass at 1 minus mass at 2 is equal to dmCV by dt. This is also 0. Yeah, you can say that like that. Mass flow rate at inlet minus mass flow rate at exit बराबर dmCV by dt. And this is 0. Why? Because STD. Now, what is the inlet? Mass flow rate at 1 minus what is the exit? M dot 2 plus M dot 3 is equal to 0. So, what is M dot 1? That means M dot 1 is equal to M dot 2 plus M dot 3. My dear, you can say very easily from this figure, okay, sir, what is the mass? M1 is equal to M2 plus M3. But why it is? Thank you. Why it is? Why? Because sometime I will ask, I asked that ki, beta, what is that? How to start, sir? There is a mass balance. No, simply mass balance is this one. Don't confuse with that energy balance, mass balance, and entropy balance. So this mass balance, that means M1. This M1 is equal to M2 plus M3. Now you have M1 is equal to M2 plus M3. Put all this value to the S generation. To the S generation. So here M1. Put M1 value here. There is M1 now. So put this value M1 here and separate M2, M3. S2, S3 with S1, S3. Okay. So if you, so this is equation number first. Let's suppose this is equation number first. This is equation number second. From first and second. Combine first and second and we get from first and second we get if you combine this one, that is your S generation, entropy generation is equal to M dot 2 if you combine S2 minus S1 minus of plus M dot 3 S3 minus S1. This is the final expression. S generation. Now some student says that, okay, sir, why we are arranging like that? That means we have this thing. Why we are not directly now proceed with the equation? Now, my dear, you don't know entropy. Mass, you have mass transfer at 2 point, mass transfer at 3 section, mass transfer at 1 section, you have. I know that. But, what is the entropy? Specific entropy at point 2, you don't know. What is the specific entropy at point 3, you don't know. What is the specific entropy at point 3, you don't know. But this is for ideal gas. Why? Because this is air. So, for the air ideal gas, you know the change in entropy. You know the change in entropy. That means S1 minus S2 you have, S1 minus S3 you have. This entropy minus this entropy you have, this entropy minus this entropy you have an entropy relation for the ideal gas. If you don't know, you are not supposed to be qualifying to 2024 examination. Why? Because this is very simple expression for that entry to when we are entering into the entropy chapter. That is the first class lecture. Okay. So what we know that like that entropy change, that means S of exit, it is like that. Entropy change S exit minus S of inlet is what? Cp ln T2, that means T final by T initial minus R ln P final by P initial. You know this thing. This is you know. Now my dear, for ideal gas, this is for ideal gas. Ideal gas. Now you know all these things. And what is that? So here if you write S2 minus S1, S2 minus S1, S2 minus S1, so what is that? Cp ln T2 by T1 minus R ln P2 by P1. You know this thing. What is S3 minus S1? Cp ln T3 by T1 minus R ln P3 by P1. You have this one. Clear? Put this value, find the answer. What is that problem? No problem, nothing is there. So S generation, if you write this one, m dot 2 S2 minus S1, Cp ln T2 by T1 minus ln R minus R ln P2 by P1 plus m dot 3 Cp ln T3 by T1 minus R ln P3 by P1. Okay? Put all this value. What is the answer? The answer it is. Now the calculation is very important. If while you are putting the value according to a given data in the question, be careful. 90% chance to get a mistake here. So be careful while you are putting the value. Why? Because all the data is given in the question. So while you are putting the value, be careful. So if you put all the values here, the answer is 2.24 kilowatt. Clear? This is clear? Everyone please? This is clear, beta? Everyone please? Is there any problem? Is there any problem? Please tell me. This is clear or not? Please tell me, everyone. So this is again, I am asking that 2.237. All right, 2.237. 2.237. Rahul, it is clear, beta? Okay. So this is again the. So what you feel that this is question tough, moderate, or easy, Rahul? This question is tough, moderate, or easy? 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 Everyone, please reply in the comment box. This question is tough, moderate, or easy? What do you feel in the examination hall? While you are solving this question, what do you have to feel? This question is tough, moderate, or easy? This question is tough, moderate or easy? Everyone please. Moderate, easy. Yes, correct. Moderate to easy. This question is moderate to easy. Very good. This question is moderate to easy. But previously, the question, it is this one. This question really tough. This question is very lengthy. Why? Because all the calculation, there is many calculation is there. This is so that this question is easy. This question is easy, but the concepts is there. Now this question is moderate. This question is moderate. Okay. Now we have to go to the next problem. Go to the next problem. What is the next problem? See this one. Yes. Read this question, Vita. Read this question carefully. What is this? At steady state, 500 kilojoule, 500 kg per second of steam enters the turbine. So there is a turbine is there with a specific enthalpy. That means what is the fluid energy which is inlet is 3,500 kilojoule per kg, and a specific entropy is 6.5 kilojoule per kg Kelvin. It expanded. Why? Because from the turbine the fluid is expanded reversibly. This is very important. Expanded reversibly. That means the turbine is internally reversible. In the turbine to a condenser pressure, that means a low pressure. Condenser pressure is a low pressure. Okay. During that heat loss occurs reversibly. That means also heat will reversibly. Okay. That means internal and externally both are reversible. Okay. In the turbine at a temperature of 500 Kelvin. Okay. If the exit a specific enthalpy and a specific entropy it is given, okay, respectively, work output from the turbine. You have to find the work output from the turbine. Okay. You have to find the work output from the turbine. This question is clear, beta? This question is also very important. Work output from the turbine, and the work output it is in megawatt. Also be careful. Okay. Clear? Okay, now let's start. So this is a turbine. Okay. This is a steam turbine. The fluid is in and fluid is exit. Okay, now so this is a steam turbine. Now this steam turbine, if you have to suppose to be that. Okay, let's suppose this is your inlet section. Let's suppose this is your inlet section, beta. This is your inlet section, section I, and this is your exit section E. Inlet and exit. Okay. During that, there is a work. If you transfer the fluid, that means there is a mass in, mass flow rate, and there is a mass flow rate exit. Okay. While entering and exit, the the turbine will develop a work, and it also loses the heat. Heat out. Work out. In the question it is saying, this says that what is the work out? What is the work out? During that, what is the work out from the turbine? Okay. All the condition it is given. Here it is the entropy, enthalpy it is given. Here entropy, enthalpy it is given. Okay. Okay. So here, once again. Okay. So here is the mass flow rate at inlet MI. M dot. It is given 500 kg per second. Enthalpy it is given 3500 kilojoule per kg. It is given. Specific entropy it is given 6.5 joule, kilojoule per kg it is given. Okay. Now at exit it is given H is equal to 2500. Exit enthalpy it is given 6.3. Now my question is that, one question is that from the data value, entry entropy is 6.5, exit entropy is 6.3. Why the entropy is reduced? Please tell me. Why the entropy will reduce? Anyone, please? Why the exit entropy will reduce? Anyone? Why the exit entropy will reduce? Why? Because it will lose the heat. Otherwise, if there is a isolated, insulated, there must be reduction in temperature. Why? Because this is a expansion. Otherwise, during the, why? Because see, high energy, high entropy. Low energy, low entropy. Why? Because after the expansion in the turbine, the fluid at, so you may suppose to be like that, there is a turbine, from the boiler, the fluid is in at the turbine, and it is exit to the condenser. So it is from the turbine, it is to the condenser. So from the turbine, from the boiler, what is the fluid is coming to the turbine inlet that have a high energy, See my dear, Rahul, entropy change doesn't, in entropy change, it doesn't involve any work. So the work production and heat loss, that statement is wrong. Entropy transfer, this is entropy transfer, SISE. Entropy transfer only by heat and mass, not work. So work produced, it is wrong. If you write heat loss, that is okay. That is okay. But work producing, due to the work transfer, there is no any entropy transfer. Mind it. I always say you that type of that approach should be very clear. Though there is a work transfer, but due to the work transfer, there is no any entropy transfer. But due to the heat transfer, there must be entropy transfer, and there is a mass in, mass exit entropy transfer. Clear, Rahul? Not work produced. It is not caused by the work produced. Okay, so entropy doesn't related to the work transfer. Very clear. Yes, only because of heat transfer. Very clear. Now again, the second question is come, if there is a adiabatic, there is no any heat transfer. There is no any heat transfer. That means adiabatic. Also there is a reversible. Why? Because the question is saying that reversible. So adiabatic and reversible, there must be isentropic. So what is the entropy at inlet and the same entropy at exit? But there is a heat transfer. So this is the example of reversible and non-adiabatic. So reversible, non-adiabatic, if you extract the heat, entropy must be reduced. Clear? Clear? Reversible, non-adiabatic, if you extract the heat, entropy must be reduced. Reversible, non-adiabatic, that means if you add the heat, entropy must be increased. So reversible, non-adiabatic, it is not like that this is the isentropic. No. Reversible, non-adiabatic, maybe entropy increase, maybe entropy decrease. That will depend upon what is the amount of heat will extract and what is the amount of heat will add. So if you add the heat, entropy must be increased. If you take the heat, entropy must be decreased. Clear? 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 So here, since expansion, this is expansion takes place, the expansion in the turbine, is reversible. Thank you, Nimrata. And you are also late in the class. That is not good. You present the class at sharply 6 p.m. Okay? So don't keep in mind, okay? Okay? More information, okay? The class is more informative, okay? So keep in mind the class will start at a 6 p.m. So be present, be there at a sharply 6 p.m. That is the sign of the very good student. Okay? So since the expansion in the turbine is reversible, that means there is no entropy generation. No entropy generation. That means S generation is equal to 0. This is the first click. Thank you. Thank you. No problem. No problem. So this is the first click. If you don't, if this information, while reading the question, while you have to read the question, if you not get this information, the chance have to get a very, very high chance to mistake. Okay. So no entropy generation. That is the first question. Things. Now we have to find the work transfer, and there is also a heat transfer. Now, my dear, see. So there are the balance. First is the mass balance. Second one is the energy balance. Third one is the entropy balance. So in this question, if you find work, what is the hint is that? Very important. What is the hint is that? Here is asking the work transfer. And work is the kind of energy transfer. So first apply the energy balance equation. Okay. So write energy balance equation. Now, number first. Okay, that is clear. Now, the energy balance is have a 3 domain: energy balance for the closed system, energy balance for the open system with a steady device, energy balance for the open system of unsteady device. So this is what kind of device? This is for the steady device. Why? Because there is no any property within the system will change with respect to time. So that is not steady. So we have to apply energy balance for steady device. Energy balance for steady device. What is the energy balance for the steady device? You know this thing? The energy equation. Okay. What is that? Heat transfer plus mass transfer into, along with that entropy in, velocity at inlet square by 2 plus potential energy at inlet is equal to work transfer plus mass at exit, enthalpy at exit, kinetic energy at exit, and potential energy at exit. If you don't know, you cannot solve the exam question in the examination. Okay. So this system is stationary. This system is stationary. So while if you keep the system is stationary, you can assume that there is no any change in kinetic energy and potential energy. Mind it. But if there is a nozzle, you cannot ignore the kinetic energy. Why? 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 Because the purpose of nozzle is to increase the kinetic energy at inlet. Okay. So there is no any kinetic energy, potential energy, kinetic energy, and potential energy. So what is that? Heat transfer plus mass into HI, mass flow rate, is equal to work transfer plus mass transfer into HE. Now, my dear, here HI, here mass transfer at inlet and mass transfer at exit are same. Why? Because this is the steady device, number first. And there is also single inlet and single exit. That means single stream device. What is that? Single stream device. That means single inlet, single exit. So what is the in? The same is out. What is the in? The same is out. So mass at inlet is the same mass of exit. So we have to, that means mass at inlet. Okay. So mass at inlet is equal to mass at exit. You can assume that mass. That is a certain mass value. Okay. So this is the equation of steady flow energy equation. Okay. You have enthalpy at H1. Why? Because see, you have enthalpy at H1. This one you have enthalpy. See, it is given that the turbine with the specific enthalpy, with the, what is that? A specific enthalpy at inlet is 3500 and a specific and heat loss if the exit specific enthalpy is 2500 kilojoule per Kelvin. Both are given. So you have HE, HI. You have heat loss. Heat loss it is given. Heat loss. Yes. Heat loss occurs. No, heat loss it is not given. But the heat loss occurs at this temperature it is given. Achha, okay. Please tell me, what is this temperature? 500 Kelvin. What is this temperature? What is this temperature? This temperature is for the system boundary of a turbine. Yes, see, heat loss occurs reversibly in the turbine at a temperature of 500 Kelvin. That means if you have a turbine, this turbine, the heat loss. So heat loss, that means this is a system boundary temperature. This is your system boundary temperature. That means heat loss at this temperature. Yeah. So this is your system boundary temperature. This is system boundary temperature. This is a steady device of open system, and this system boundary temperature of a temperature it is given. Okay, this system boundary. So heat transfer it is not given, work transfer it is not given. Now enthalpy and mass it is given, enthalpy and mass given. So one equation, two unknown. This is one equation, and unknown is Q and unknown is W. What is that unknown? Heat transfer, and what is that unknown? Work transfer. So for one equation, two unknown, you cannot find. You cannot find the value of any quantity of a two quantity from a single equation. So what is the next step? So this is the clue towards the next step. This equation is clue towards the next step. What is the clue? Okay, sir, there is a one equation but two unknown. What is the next equation? Next equation is entropy balance. What is that? Entropy balance. So you have to balance the entropy. So for balance the entropy, you just have to write the entropy balance. To just write the entropy balance. What is the entropy balance? You know this thing? S inlet rate of entropy in minus rate of entropy exit plus rate of entropy generation is equal to ds of entropy of a control volume by dt. Now my dear, you know this thing is zero. Why? Because the system is a steady device. Steady device. This is your steady device. So this is zero. Clear? Okay. Now, please tell me, who is the responsible to transfer this entropy? Who is the responsible fellow to transfer this entropy? Please tell me. Who is the responsible fellow to transfer this entropy? Please tell me. Who is the responsible fellow to transfer this entropy? Mass and heat. Very good. The entropy transfer, here mass is in also, exit is also, that means mass transfer, and also there is a heat transfer. So this question, both are the responsible. That means heat and mass, both. Very good. Not only by mass, not only by heat, but both. Okay. So what is the entropy in due to the mass? No, Rahul, wrong. Heat and mass both. Right. Very good. Heat and mass both. Okay. So what is the entropy in due to the mass? M dot into SI. This is the entropy inlet due to the mass. No. What is the entropy inlet due to the heat? Zero. Why? Because there is no any inlet. Heat is exit only. No inlet heat. So this is zero. Now, What is the entropy minus? What is the entropy exit due to the mass? Mass m dot into S exit. Clear? And what is the entropy exit due to the heat? Very good. That means we have to write plus or minus. Minus. Why? Because heat out. So plus of minus Q out divided by what is the temperature? This temperature? This temperature is temperature of surrounding or temperature of system boundary? Please reply in the comment box. If this temperature is there, which temperature is there? This temperature is system boundary or surrounding? Please tell me. Please tell me. This heat out, which temperature you have? This temperature, which temperature you have? Please tell me. If there is a surrounding temperature it is given, and if there is a system temperature is given, which temperature you have to take here? Which temperature you have to take here? This temperature of surrounding, the system, boundary. Yes, very good. System boundary. That means if this is your turbine, so these are the system boundary. And through the system boundary, heat will transfer. So this heat transfer through this system boundary. Okay. So heat transfer system boundary. So this heat transfer at a system boundary. So system boundary plus S generation is equal to 0. Now put all this value. Mass flow rate it is given 500. Entropy at inlet it is given 6.5. Minus mass transfer at exit it is given 500. Entropy it is given 6.3. And this minus is plus. So plus heat transfer, heat out. This is not minus, this is minus. Heat out, okay. So this is plus. Okay, minus heat exit. So it is out. So from heat out divided by T, temperature is 500. Okay. And what is the generation here? Beta? Please tell me. What is the generation, Rahul? What is the generation? Generation is 0. See, since the expansion in the turbine is reversible, so generation is 0. Very good. So generation is 0. Is equal to 0. So if you find heat transfer out, the value it is how much? 50 megawatt. 50 megawatt. 50 megawatt. Now, once you have a 50 megawatt, put 50 megawatt, you have a mass, you have an enthalpy, put this value here. That means this is your 50 megawatt, that means this is your please. So this is heat out. So heat out is negative. So minus of 50. अब not put megawatt. This is your 50 watt, kilowatt. 50,000 plus what is the mass? 500. What is HI? 3500 kilowatt. This is a kilowatt. Why? Because this is a kilojoule. Is equal to work transfer plus 500 into 2500. Okay. Why this is negative? Why? Because this is heat out. How out is negative? So put the negative value plus mass transfer M HI. Why we have to write? This is a megawatt, but we have to write kilowatt. Why? Because this is given 3500 kilowatt. It is given. See, 3500. Sorry, kilojoule. This is kilojoule. So we have to write in kilojoule. So we have to write in kilo basis. So this is kilojoule, kilowatt. Okay. So this is dot. That means this is also kilowatt. This is also kilowatt. This is also kilowatt. So what is the work here? If you find the work transfer, it is your 450 megawatt. Clear? This is clear, beta. Everyone, please, if you have any confusion, please ask me. I can repeat. No problem. I am very happy to again revise this question because this question is very important. This is clear, everyone, please tell me. This question is clear, beta. This question is clear, please tell me. This question is clear, please tell me. Is there any confusion? Okay. So these all are the question. These all questions are related to the entropy. My dear, I am humbly request you. I want to request you. You can revise only this questions from the entropy chapter. You must have to solve all the numerical problem related to entropy. And for this two, approximately 6 and 7 question, if you revise this, 2 marks is fixed. Damn sure. Damn sure the 2 marks is fixed. No any problem at all. Okay? So, what is that one? Say, my dear. So, what do you think, Rahul? This question is tough, moderate, or easy? 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 Please reply in the comment box. This question is tough, moderate, or easy? What you think? This question is tough, moderate, or easy? Okay? Okay, don't bother about that. Okay? This question is moderate. This question is moderate. Very good. This question is moderate. 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 Okay. Now, we have to write the next one, and next one is for that power plant. Yes. This is for the power plant. Okay. A steam power plant based on the Rankine cycle. Okay. Just comment gas turbine based on everyone. This is the steam turbine based on Rankine cycle. Gas turbine? Yes, energy balance and entropy balance. This question related to the Rankine cycle. Okay, steam turbine based on the Rankine cycle. I want to ask you, the gas turbine based on a which cycle? Please write the comment. Gas turbine based on a which cycle? Gas turbine based on a which cycle? Please tell me. Breton cycle. Very good. Okay. In steam power plant based on a Rankine cycle, steam is initially expended in a high pressure turbine. Very good. Very good. Steam power plant based on a Rankine cycle, steam is initially expended in a high pressure turbine. The steam is then reheated. Okay. What is the purpose of reheating, beta? Anyone? Please tell me. What is the purpose of reheating? What is the purpose of reheating? Please tell me. What is the prime motive to reheat? What is the purpose of reheating? Please tell me. What is the purpose of reheating? Please tell me, everyone. What is the purpose of reheating? What is the purpose of reheating, beta? Please tell me. What is the purpose of reheating? Okay, just write down. I will see. So reheated in the reheater, and finally it will expand in the low pressure turbine Very good, Rahul. Very good. I am very happy. To increase the dryness fraction, to increase the quality of the steam. Quality of the steam. Yes. Yes, very good. So that the blade erosion is not taking place. Very good, very good, very good. Okay, so reheated in a reheater and finally expanded in a low pressure turbine. The expansion work in the high pressure turbine, this is given expansion work, and the low pressure turbine expansion work it is given. Whereas the pump work, you have to pump work it is given. Yes, yes. If the cycle efficiency it is given 32%, the heat rejected in the condenser. What is the heat rejection? Okay. What is the heat rejection? Okay. So my dear, this is your steam power plant. And see, this is your steam power plant. There is a boiler. So there is, from the boiler, the high pressure and high temperature steam will flow through the pipe and go to the high pressure turbine. This is a high pressure turbine. And what is the reheater? What is the purpose of reheating? You take all the steam from the high pressure turbine and again you have to reheat in the reheater. And in the reheater is the part of the boiler. That means in this, you have to go to the reheater where the temperature is increased but the pressure is constant. That means the reheater pressure is constant. Again you have to go to the low pressure turbine where the expansion will take place and finally it will go to the condenser. Then we will enter into the pump and again it will into the boiler. Okay. So what is the process? What is the process of reheater? 4 to 5. So 4 to 5 is a reheating process. That means you have to reheat the steam again and again you have to supply to the low pressure turbine. Now in the question they are asking that what is the heat rejection from this condenser? Okay. So what is that reheating? Steam after expansion the high pressure turbine is sent again to the boiler and reheat till it is reheated to the superheated condition. That means the exit condition after the reheating must be superheated. Superheated condition, it is then sent to the low pressure turbine to expand till it is condenser pressure. So that the efficiency, if a dryness fraction, that means quality of the steam will increase. Now my dear, the TS diagram, this red line is a saturation curve. What is that? Saturation curve. So there are two pressure. This is your condenser pressure and this is your boiler pressure. Now 1 to 2 there is a pump. After that you have to add the heat to the steam and it will expand to the high pressure turbine. It will expand to the high pressure turbine. Again it will go to the boiler to reheat. So this is your reheating. Again it will expand to the low pressure turbine. And in this question, what is the heat rejection to the condenser? Clear? What is the heat rejection to the condenser? Clear? This question is clear with everyone? Please tell me. Reply in the comment box. This question is clear with all? Clear everyone? This question is clear? This question is clear or not? Please tell me. So, what is the efficiency of the cycle? What do we know that? What do we know that efficiency? Net work by heat supply. This you know that? Now, what is the network? What is the network here? What is the network here? Work done by the high pressure turbine plus work done by the low pressure turbine minus work done on the pump, WP. Yes or not? High pressure turbine plus low pressure turbine minus pump work. Okay. This is clear, these two things. Efficiency of the cycle is W net by heat supply. This you know that. And what is the net work? Work produced by the high pressure turbine. Work produced by the high pressure turbine. Work produced by the high pressure turbine. That means this work will produce W high pressure turbine. Work produced by the low pressure turbine, and this is your work input to the pump. So what is W net? W net is work high pressure turbine plus work low pressure turbine minus pump work. Clear? Minus pump work. You have to find what is the heat rejection, Q out. In this one, there is a heat addition. There is a heat addition. And this is your reheating. This is your reheating. Okay. So start this problem. So this is your TS diagram. This is your TS diagram, beta. This is your TS diagram. This is saturation curve, temperature and entropy. So there is one condenser pressure, there is one boiler pressure. So this is your boiler pressure, this is your condenser pressure. Okay? This is your boiler pressure, this is your condenser pressure. Okay? So 1 to 2, there is a pump. After that, it will reach to the boiler. Here, this is the expansion from the turbine. Expansion from the turbine. So this is expansion from high pressure turbine. Again, it will reheated. Again it will reheated, and then again it will expand to the low pressure turbine. 2, this is 3, this is 4, this is 5, this is 6. My dear, one thing is note down here. Two things. First one is that it is not necessary that T3 is equal to T5. It is not necessary, but we can take like that. It is not necessary. Also, it is not necessary that expansion up to saturated vapor. No, it is above that or below that. No problem. This 5 point above 3, below 3. Clear? Clear? Okay. Now, it is not necessary T5 is equal to T3. We are taking like that as usual. No problem. Okay. So, this is your pump work. In this one, there is a pump work. Okay. These are high pressure turbine work, low pressure turbine work. And this is your reheating. Okay, this is your reheating. What is given here? Work by high pressure turbine. What is given? 400 kilojoule per kg. Work done by low pressure turbine, that means work transfer by the low pressure turbine 850 kilojoule per kg. Work transferred to the pump, it is your 15 kilojoule per kg, and cycle efficiency 0.32. Okay, cycle efficiency 0.32. We have to find Q out, heat transfer by the condenser. So this is your Q out. Okay. So we know that efficiency of the cycle is equal to W high pressure turbine, W low pressure turbine, pump work by heat in. So from here, high pressure turbine work, low pressure turbine or pump work efficiency it is given. So from easily you can find what is the heat in. So heat in is 3859.37 kilojoule per kg. This is heat in. This is heat in. Now, from the standard definition of the efficiency, what is that? W net by heat in, and that W net is for the cycle is what? Q net. That means Q net, W net for the cycle is equal to Q net by Q in. What is Q net? So this is from which law? This is from the first law for the cycle. First law of TD for cycle. Now what is net? Q in minus Q out divided by Q in. What is that? 1 minus Q out by Q in. Now you have this efficiency. What is that? 0.32 is equal to 1 minus Q out you have. What is Q in? Q in is 3859.37. From this one you have to find Q out. Q out it is your 2624.37 kilojoule per kg. Clear? This is clear, Uda? Anyone please? Is there any problem? Please tell me. This is clear? Everyone please tell me. Reply in the comment box. This is clear, Uda? This question is clear? Very simple question, but this is very good question and expected question to ask in the GATE examination related to this problem, not exactly. Clear? This is clear? Now, my dear, I give you one. Okay, thank you, Rahul. Okay, I give you one information. Okay, Rahul, you are in 30. You are pass out. You are in final year. You are pass out in final year, beta. Anyone, please give me. Everyone who is at right now, who is watching, please give the information. You are final year or pass out. So if you are pass out, I suppose to be that you have a much more score in the GATE. Okay, much more score. Why? Because you have pass out and you know all the subject during the semester examination. Just you know that, and after that preparation you can get more and more score. So you all are who is here at this time, I suppose to be that you have a good ranker, and it is a very thankful to me that. Acha, Rahul Kila mechanical. Yes. Okay, beta. Last year I knighted Rahul Kila. So you are the deserving candidate, and I have a best wishes that you have just qualified more and more good rank. Okay. So just go through this problem. Today I will end up this session here, and from the next session I will just you can join this Telegram group. You can join this Telegram group, beta, so that the update will come when So you can join this Telegram group, and the update is come when the classes is going on, when this classes is going on. Okay, so you have to join this Telegram, and we have to discuss with the and I will take the Gate Booster series of thermodynamics already, and fluid mechanics and machine design. So fluid mechanics I will go beyond the level. I will start with the beyond the level. Why? Because in the fluid mechanics both branches are common, civil and mechanical engineering. So we have to give the more and more effort. Okay. Okay, good. Triple point wali question. Okay, beta. Okay. Okay, so what I have to do, triple point, that is the question of triple point. So if there is a first session, if you may ask, that is at 2nd December. So I supposed to be solve this problem, but don't bother about that. I will just this question note down triple point. So which year this question, beta? Triple point, I remember that question, but which year this question is asked, triple point wala question? So I will just comment this question, okay? Triple point question answer, we will discuss all the things, okay? In the upcoming, if next session we have a fluid mechanics, but we have to discuss this triple point questions for you for first 10 minutes, okay? So if you have any information about that question, just post your comment. What that only 2 and 3 line after the class anytime. You have a 2-3 days is there. So you just write that language of that question only, so that I will able to know that which type of question you want. Okay, Gate 2022. Okay, understood. I will discuss in the next session. Next session is the fluid mechanics, and I will discuss this question. Damn sure, it's my promise to you. Okay. It's my promise to you, I will discuss this question, okay? Meanwhile, you can post your comment so that I will understand that where you have a problem in this question, okay? Up to that, thank you, bye-bye, stay tuned. Good luck, beta.